So let's get started with DynamoDB. DynamoDB is advertised as a NoSQL serverless database. Now, these three words have a lot of meaning in it, so let's do a deep dive. When you have a traditional architecture, we've seen what it looks like. There's our client and it talks to our API layer, and traditionally that API layer may be formed of a load balancer, an auto-scaling group, maybe some EC2 instances. And our EC2 instances will talk to a database layer. For example, RDS, such as MySQL, PostgreSQL, Oracle, etc., etc. So we've seen this architecture in and out. And so these traditional applications, they leverage something called RDBMS database. RDBMS stands for relational databases. And these databases, traditionally, they use the SQL query language. Now, SQL, if you don't know about it, it's a very intuitive query language which allows you to quickly find information into databases and join data. Now, these databases have strong requirements about how the data should be modeled. It should be in tables, in rows, and they should have joins and indexes. And the benefit of this is that you're able to do within the database some joins, some aggregations, some computations. And so these databases can become quite compute heavy very quickly, can become very costly. And so if you want to scale them, so if your application gets bigger, usually that means vertical scaling. That means we're getting a more powerful CPU, more powerful RAM, better disk, but you just make that database a little bit bigger, such as it can handle the load coming from your API layer. Now this works just fine. And to be honest, this architecture is powering many databases and websites in the world. But there's a new type of architecture that is emerging, which is called NoSQL database. Now, just to be clear, NoSQL doesn't mean it's not SQL, it means not only SQL databases. And so what does that mean? That means that they're non-relational databases and they're distributed. So this is a stark difference with the relational databases that we had to have one and scale vertically. These ones are non-relational, so we can't do joins, and they're distributed, so there's going to be some kind of horizontal scaling. These databases can include the very popular MongoDB, but also for the cloud, DynamoDB. NoSQL databases, unless there's a little feature added to it that do not support join, they expect you to have all the information you need within one table or to do the joins client side. All the data should be present in one row, so we'll see this. And the NoSQL databases don't perform any computations for you, such as sum. All they do is give you the data you need very efficiently. Now, the NoSQL databases, they scale horizontally. So this is why this is a very good fit for serverless. It's because we're going to be able to scale our NoSQL database or DynamoDB without doing much work. And that's because of the design of the database. Now, there's no right and wrong if you choose NoSQL or SQL. They basically require different model of data and they require to think about your queries differently. But for the use cases where NoSQL is good, it's usually very powerful and allows you to scale your website a lot. Now, this whole section is going to be about understanding how DynamoDB works and understanding the power of NoSQL databases. So let's have a look into DynamoDB. DynamoDB is going to be fully managed, highly available database with a replication factor across 3 availability zones. So by default, you get a lot of good stuff. It's a NoSQL database, as you expect, so it's not relational, and it scales to massive workload because it's distributed and horizontally scales. And so this has been proven. Some companies have hundreds of terabytes into DynamoDB, and it works just fine. Now you can scale to millions of requests per second, trillions of rows, or as I said, hundreds of terabytes of storage. So this should fit your use case if you are a bit smaller than this. It's good because it has a fast and consistent performance. And this has to do with the fact it's distributed. So there's low latency when you want to retrieve data. And this is a choice around it being a NoSQL database. And on top of it, because it's in Amazon, you expect it to be integrated with IAM for security, authorization, and administration. And because it's serverless, we don't have to manage anything. So this is why it's called a serverless database. We don't see the servers, we just provision the tables. Now there's a little feature that we'll see in details later on, but you can do event-driven programming with DynamoDB streams. And finally, it's very low cost and has auto-scaling capabilities, as you would expect for any serverless technology. Now for the basics. It's made of tables. So just like a normal database, DynamoDB is made of tables. and each table will have a primary key, just like a traditional database. But this primary key is a little bit different. We'll see this in a few slides. Now, each table can have an infinite number of items, and items is the same as rows. So I will use items and rows interchangeably in my speech. Each item can have attributes, and attributes can be added over time, and they're basically equivalent to columns, but a little bit more because these attributes can be nested. And so the items can be attributes, and because these can be added over time, there's less restriction than SQL databases, and some attributes can be null. Now, the maximum size of a row or an item is 400 kilobytes. So you can pack a lot of information into one row, and this is encouraged. Now, in terms of data types supported, we have all the scalar types we would expect, so string, number, binary, boolean, and null, but also a little bit of non-traditional types, which is called list and map. So we're able to have list as an attribute or a map as an attribute, and set. So set of strings, set of number, binary sets. So these basically allow you to do nested stuff within your documents, within your items and rows. And so this is what's going to be different versus an SQL database. Now let's do a deep dive into this primary key because it's super important. The first option is to have a partition key only, and this is called a hash. And so the partition key is equal to your primary key then, and it must be unique for each item. Otherwise, it's not a primary key. And so because it's called partition key, that means it must be diverse enough so that the data is going to be distributed across many partitions. So if we take a users table, user ID is a great candidate. So user ID is our partition key, and it's going to be unique. And in terms of attributes, we can have first name, age, whatever you want. And so the first row or first item is going to have a user ID of whatever. And you see this is pretty much random. And the first name is going to be John, and this age is going to be 46. The second row or second item is going to be another user ID with a different user ID, obviously, because the partition key has to be unique. And the first name has to be Katie, and the age has to be, for example, 31. So this looks like a traditional table. The option 2 is what makes more DynamoDB specific, which is that your primary key can be a combination of a partition key and a sort key. And so the combination of the partition key and the sort key must be unique. So this is why it's called a primary key. But the data is going to be grouped physically by DynamoDB under a partition key. So all the data sharing the same partition key will be together. And then it will be sorted by the sort key. Sort key is also called range key. And so this is going to allow you to do some very efficient queries. So if we look at a user's game table, for example, users play games, we can use user ID for the partition key and game ID for the sort key. And this is just an arbitrary choice. But we know that the combination of user ID and game ID is going to be our primary key because it will be unique. A user can have many games, but a user can only play one game ID overall. So this is why the combination of those is a primary key. And in terms of attributes, we can still have, for example, the result of the game. So if we take our first row, we have our first user and it's playing a game ID 1234 and it wins. And maybe the same user, you see the partition key is the same, plays another game, and maybe this time it loses the game. And so as we can see here, the partition key is going to be shared, duplicate, but the sort key is going to be different. And so the combination of partition key and sort key is going to be unique. So in the exam, it's going to ask you to find the partition key that's going to be optimal for distribution of data, for example. And so say we're building a movie database and we have movie ID, producer name, lead actor name, and movie language. What is the best partition key to maximize data distribution? In this case, it's going to be movie ID because it has the highest cardinality, so it's a very good candidate. If you take, for example, movie language, it's going to be a few languages only. Maybe all the values or most of the values are going to be English. Maybe it's an English movie database. So maybe most of the values are going to be English. So it's not a great partition key because otherwise all the data is going to be skewed into one partition. So that's it for just the overview of DynamoDB. In the next lecture, we're going to go a bit hands-on through the console, but I just wanted to give you a soft introduction to it.